Hello class, you've made it to chapter 11. This video will talk about some of the concepts in section 11.1, and chapter 11 has to do with nothing but quadratic equations, which means that we are always going to have an x squared term, and 11.1 and 11.2 both talk about different ways you can solve a quadratic equation. So remember, when you see the word solve, every problem is going to come with an equal sign. I'm going to spend, this isn't actually in section 11.1, but you do actually know an additional way just from section 5.7 on how to solve a quadratic equation by factoring. So if a problem can be factored and you're given the choice as to which method to use, this is always available. So this problem here, our first example, can be factored. X minus 5, x plus 4. And so you know we just switch the signs because we're going to set each factor then equal to 0. And so x equals positive 5 or x equals negative 4. Just to review, if we have a squared term, we should anticipate two different answers. Also, the same answer could show up twice, but that's considered, it's one answer, but it happens two times, so it still falls into that two answer category. Let's review a slip and slide by factoring. So what if we have 6x squared minus 13x minus 5? Another piece to remember is that in order to solve by any of the methods I'm going to show you over the next two sections, the first step is to make sure it's set equal to 0. So this one already came like that. In order to slip and slide, we multiply the a and the c. We find two factors that are going to multiply to or add up to a negative 13 and multiply to a negative 30. It's not maybe going to be your first impulse, which might be 10 and 3. We're going to choose 15 and 2. And that way we know we have one positive factor, one negative factor, so that it multiplies to that negative 30. When I solve each factor, I'm going to get the answer positive 15 and negative 2. So that's just a short review of what is in section 5.7. We should be great at factoring by now, probably. And so in 11.1, the very first lesson we see is solving by something called the square root method. All right, so the square root method looks something like this. We are going to isolate. Remember, that's just that fancy word that means get by itself. We're going to isolate the square, and then we're going to square root both sides. It's super similar to kind of just the inverse, the opposite of what we did in section 10.6. where we got the squared term by itself, and then we had, or the square root by itself, and we had to square both sides. Here we're going to get the x squared term, or whatever is being squared, by itself, and then we're going to take the square root of both sides. It's also important to know that in chapter 10, when we looked at something like the square root of 25, we decided at the beginning of the chapter, hey, from here on out, we're only going to take the positive answer. Chapter 11 says scratch that. And we're back to, if we square root something, we take both the positive answer and the negative answer. And you'll see that when I work through the problems. So that might be just a little confusing because the rules switched yet again. All right, so here's our first example. X squared equals 144. You can tell the squared term is isolated, so we take the square root of both sides. So x equals both a positive 12 or a negative 12. There is a fun little symbol And that way it looks like this. It stands for plus and minus, and that way you don't have to write the number out actually twice. It just takes the place of writing the number twice, plus or minus 12. Let's do another one and build from this example. If we have a coefficient in front of that x squared, maybe something like that, we're going to divide by 5 and get that x squared by itself. So x squared equals 3, square root both sides. Notice in this example, there's nothing I can do with the square root of 3. It doesn't simplify. It's not a perfect square. So our final answer is plus or minus radical 3, and that's it. What happens if we have an add or subtract involved? Well, we can look at something like maybe something like that. So now we have to move the 1 over. So 9x squared equals 81. Divide by 9, divide by 9. So x squared equals 9. Square root both sides. 9 is a perfect square, so my final answer would be plus or minus just the integer 3. All right, there's all sorts of possibilities here. We could end up with a negative answer, so we could have something like this. So if I move that 49 to the other side, it turns negative. So x squared equals negative 49. Square root both sides. Prior to 10.8, this would have had no answer to it because you can't take the square root of a negative. But now we understand about imaginary numbers and pulling that I out. And so if you recall, we're going to split that. We have the square root of 49 and the square root of negative 1. This becomes plus or minus 7, and the square root of negative 1 is I. So if you did not really go through that whole process of 10.8, it does come back in chapter 11, and I would encourage you to watch the video, do the homework, look at all the practice examples. All right. Let me check and see what other examples I have here written out. Oh, here's a good one. You may end up with a number under the radical in the denominator. So divide by 3, divide by 3. So you have x squared equals 10 thirds. So you need to square root both sides. So now we have plus or minus the square root of 10 over the square root of 3. We do not want a radical in the denominator of our fraction, so we're going to multiply the top and the bottom by radical 3, which is going to change that square root to the numerator. 3 times 3 is 9. The square root of 9 is 3. And so that is our final answer there. All right, sometimes we're going to have more than one term that is being squared. So you might have something like this, x minus 1 squared equaling 9. It doesn't look like the square is isolated here, but it actually is because it's this entire quantity that's being squared. So right here, we're ready to take the square root. When you square root something that's been squared, you can do that similar step that we did in section 10.6. You can just kind of scribble it out. And this x minus 1 breaks free. It doesn't change in any capacity. On this side, however, when we square root 9, we still need to take that plus or minus option. So it's going to look like that. Let's add 1 to both sides. So we have x equals, now watch how I'm going to write this. I'm going to put that 1 first, plus or minus 3, and then I'm going to split it because I still have two answers. So I'm going to have 1 plus 3 and 1 minus 3. So one of my answers is going to be positive 4, and one of my answers is going to be negative 2. Not every one of these will have a perfect square here. So if this does not work out nicely, like the next example, I'll show you what to do. So x plus 3 squared equals 12. Again, we don't have to move anything. We don't have to add, subtract, divide. We already have that square term isolated. So we're going to go straight to square rooting both sides. This is going to cancel out. So we have x plus 3. Over here, we're going to have plus or minus the square root of 12. What's unique about this problem is that 12 can be simplified. So those skills will still come back to play in chapter 11 as well. We need to look for our pairs. One guy cancels. Anything that's circled breaks out of the radical, and anything that's not circled stays underneath. So this is x plus 3 equals plus or minus 2 radical 3. And let's bring that 3 to the other side. I would write that negative 3 first. I'm hoping you can still see the screen. X equals negative 3 plus or minus 2 radical 3. Because this can't go any further, if you split it up, nothing really would be able to add or subtract or combine anyways. This is acceptable to leave as your final answer. So you need to get used to kind of seeing that form as well, and you'll see that in your book also in the answers to your homework. All right, this is half of 11.1. The other half is called completing the square. It's a little bit more complex, so I'm going to stop this video, but this is not the end of 11.1. So stay tuned. Thanks for watching.